before.
Take it away.
All right, guys. So here's our Sippy Cup machine as you just saw in the presentation. It's all PLC and HMI controlled. A lot of the manual control goes on at the HMI here, but the real brains of the operation are in the PLC in the back panel there. If you go over to your menu screen, you can see the hand and operation modes, the different modes. Right now I'm just going to show it in hand mode because that's what we got working this semester for the most part. Over here on your pick and place, you're able to actuate the different parts of the pick and place by themselves. So you can go horizontal, you can go vertical, and it's just a handy way to troubleshoot it, fire it manually. Just a nice way to control the machine. But over here on your test screen, this is a screen we actually designed ourselves in order to be able to fire everything on its own and be able to actually test the operation of it. So from here you can index your conveyor to get it in the right position. You can fire your pick and place. It's going to extend down. Grab a piece of cardboard with a vacuum, release it, put it on the tray. We aren't going to run it with the cardboard right now just because, like we said, there's some issues going on with it. It doesn't always run through smoothly, and it's just easier to show it without right now. So what you see there is when the piece of cardboard gets placed on a tray, it activates position 0. That's a shift register command on our PLC, and you can track it from the HMI right here. So we're in position 0 right now. When we start to run the conveyor, that position is going to shift all the way down. It's going to show the dropping of the cups and the lids.
One time it works perfect. Yeah, don't let it jinx it.
Yeah, no, don't think so. All right. Yeah, we're missing the cup there, but that's okay. All right, so from there, it moves over to our packaging part of the system. Transducer cylinder is going to extend down, compress the package, and then the cylinder in the back, our lid folder, would act to fold over our packaging sheets if we were implementing that right now. Yeah, so it just kind of creates a more condensed package and folds everything into position. So from there it comes through and onto our auto lathe machine. Right now, I'll turn on the vacuum. Basically the way this works is you have a vacuum pressure right here that is used on the bottom of this tamp cylinder. So when this is turned on, you press the label advance, and that moves a sticker onto position. I guess there was already one on there. It shoots that one off, but it shoots another sticker, puts it on the bottom of the tamp cylinder, and from there you can manually tamp it in order to apply that sticker. Now, it didn't stick just because we're running it just with the plastic cups. If we actually had cardboard on there, it would stick a little bit better, but you get the idea. That sticker would come down.
What it should look like at the end?
Yeah. Yeah, so that's what you would end up with right there. Is a sticker fold kind of like that.
Go ahead, Brian. Tell them what you got.
Oh yeah, this is the original. This is the only one we have. They also have one in their display cabinet at the York Imperial, but that's the only thing that we have to go off of.
So that's what they've been trying to replicate. It's almost like an archaeology project.
Yeah, it's like reverse. So we make a rev, come in here, try it out, make adjustments, and then come back and do it again the next week.
Yeah. All of our design was in AutoCAD. Kyle drew up the original AutoCAD design for it, and then we just made adjustments and stuff. Basically, we just had to go back and forth to make 717, make some cuts, come back here, test it. Oh, it's not quite right. Make some more adjustments, go back, cut it, come back again. Just a cycle. And if we had maybe a month or two more, we really could have refined this process to make it a lot more effective and actually use the packaging with the machine. So yeah, if you guys got any questions?